Okay, so it's so big that we don't even know how to talk about it, and we're actually stumbling through this project because of the computer crashing a little bit. So what do you think you would do to find like the last digit of Graham's number?
Well, I don't know if this works normally, but there are only certain digits that powers of 3 can be.
Yeah, so if you start with just 3 and then you multiply, you go to the next power, you get 3 squared is 9, and then 3 cubed is 27, which has the last digit of 7. You can just use the last digit, multiply it by 3, you'll get 1, or 21, which is 1. And then you go back to 3, so it's a loop. So you'll always, if you're using powers of 3, you'll always end up with that.
Did I get it backwards? Alright, so there's our digits of 3.
So we know that there can only be 9, 7, 1, or 3.
Yeah, something's wrong. For I
That
equals
doesn't make
1,
sense.
I less than 10, I plus plus. Why didn't it start with 3? Oh. Did I forget to put a comma there? There we go. So for 3 to the 1, the last digit's 3.
Yeah.
For 3 to the 3 squared, the last digit's 9. 3 cubed, the last digit's 7. 3 to the 4th, the last digit's 1. Then 3, then 9, then 7, then 1. And why? Could you explain this pattern one more time? Why
So
does this
if
pattern
you just
happen?
use the last digit, if you multiply the last digit by 3, which is kind of what you're doing here, so you get 3 times 3 is 9, 9 times 3 is 27, take the last digit, which is 7, multiplied by 3 is 21, 1 multiplied by 3 is 3.
Okay.
So,
Alright, so there's only 4 choices for the last digit. So what do you think's going to happen to the last digit of Graham's number? Can we use this information to try to figure it out?
Well, looking here, and the 3 to multiples of 3, so 3 to the 3 ends in 7. And then 4, 3 to 4, 3 to the 5th, 3 to the 6. So it's not a pattern for multiples or powers of 3. Or actually, this is 9, right? Yeah, there's not going to be a pattern.
Okay.
So we know it's one of these 4 numbers.
Well, maybe what we do is maybe we introduce a new variable, and we just look at powers of. Could we do the towers? I'm not sure. But we know it's only 4 choices, so we know Graham's number does not end in a 6 or a 5. It ends in one of these, and let's just see if we can come up with some ideas.
well,
Because unless like all the towers started ending in the same digit at a point, kind of like the factorials do, where they're always 10s after a certain point.
well,
Okay. Well, we could check that.
you could look at multiplying by 3 to the 3, or going by 3 to the 3 because,
Oh,
That's right,
I
because
see
that's what-
something now. Because we know 3 to the 27 would just be 3 to the 7.
Well, we got to be careful about that.
How the mods.
I'm not sure how mods work with powers, but we could just forget the whole for loop here and just see what 3 to the 3 is, mod 10, 7. 3 to the 27. That would be the next one in the tower, right? That's
Yeah.
3 to the 3 to the 3. It's also 7. And then 3 to the Oh, this is the one we couldn't evaluate, right?
Yep.
This is 4.
This is 4, so we actually couldn't evaluate this. So the question is,
Well, if it does end up equaling 7.
Well, we already. It was 3.
So it does equal 7, then it's looking kind of likely that our last digit might be 7.
okay, so let's see if we can figure out why that might be 7. So if we do 3 to the 1, 3 squared, 3 cubed, and 3 to the 4th, we get last digits of 3971.
Yep.
Okay. Can you use this information to tell me anything about? Can we throw out at least 2 of those digits for being the last digit?
Well, we know that all the powers are going to be odd.
Aha.
So 9 and 1 are out.
Okay. Do you understand?
Yeah.
What? So explain that to me.
So there's no even numbers in the powers because we're only doing powers of 3, just
Okay.
stacked.
So that says Graham's number could at least probably only end in 3 or a 7.
So if you're evaluating 3 to the 3 over and over again because you're starting at the top, and then if you're just looking at the last digit, well, we already found 3 to the 20. We already found the 3 to the 27 would end in 7.
Okay.
Well, does it work for 3 to the 7? Because then it would always repeat. It's just 7.
Ah, okay. Let's see what 3 to the 7 ends in. Well, actually, you can tell me what 3 to the 7
Because then it's gonna 4 is here, so 5, 6, 7.
So 3 to the 7th is going to end
ends
in
in
a
7. So you can just take the last digit and then 3 to the 7. Just keep doing that.
Okay, cool.
So always.
So we learned Graham's number is going to end in a
7.
7. Okay. I know you got to run out the door, and this took a little bit longer than we were expecting. So, all right. Good job this morning, guys.